Welcome to our last and final plenary talk for today. It is my absolute pleasure to introduce our next speaker, Dr. Ali Arab. Dr. Arab is an associate professor of statistics and director of graduate studies in the Department of Mathematics and Statistics in Georgetown University. His research is in spatiotemporal and spatial statistics and hierarchical Bayesian modeling. He's interested in applications of statistics in environmental science, epidemiology of infectious diseases, ecology, and science and human rights. His current research is focused on developing methodological tools for studying problems in the intersection of climate change and social and natural phenomena. In particular, those projects are focused on bird phenology, climate change, climate and conflict-driven forced migration, climate change, and vector-borne disease. Dr. Arab also serves as one of the American Statistical Association representatives to the American Association for Advancement in Science, AAAS, Science and Human Rights Coalition. He's also actively involved in human rights work and is a member of the board of directors of several organizations, including Amnesty International USA and Hostage Aid Worldwide. Please welcome Dr. Arab.
So much. Thanks for the kind introduction. It's been a pleasure to be among you, great group of people. And I feel like I have a new community and I have a new set of friends. So that's always exciting. And I love, smaller size conferences because it gives us a chance to actually interact. So today I'm going to talk a little bit about sort of the framework that I see my work in, and I'm going to borrow and steal from Rebecca from earlier talk and say that the idea of purpose and goal, without really being able to articulate it the way you did, I was not, but you're doing projects, your projects end, and then you feel like, oh, so what next? But then it's the framework I feel like that, drives us. So I'm going to talk a little bit, and then I'll go over a few projects that past and ongoing projects to talk about those. So, I do have this. These things never work for me, but okay. I can use that. Thank you. So just a quick sort of outline. So I'll talk a little bit about myself and my issues of interest, talk about sort of that framework I was talking about and where data science and data science fall into that, and some related projects and some concluding remarks. So I'm an Iranian American. I'm a proud American and a struggling Iranian. And let me tell you why that is, because the first 25 years of my life that I spent in Iran, I had mixed feelings about my experience, because I went through, I was born a few years before a revolution in Iran, which turned out to be taking a really bad turn in the history of our country. And so I experienced a war and oppression of student movements and so many different human rights violations. And I should also say that I'm not saying that and I don't want to paint the wrong picture for you, that I was devastated by any of this directly. It was more of an emotional draining experience, but I was always standing on the sidelines, kind of observing, which is, I think, what statisticians tend to do. So I moved to US basically because there was no prospect of continuing to graduate studies in Iran for me, or people who were not really being conforming to the ideology of the regime in Iran. So anyways, So I came to US in 2000 and I started a master's in mathematics and statistics at Southern Illinois University in Edwardsville. It's close to St. Louis. That's the not the main campus of SIU, but the second campus. The great experience there. And then I stayed on in the Midwest and went to University of Missouri in Columbia, or as we like to call it, Mizzou, and worked with a fantastic advisor, Chris Weichel, who gave me the perspective that I for so long was searching in life, which was, put everything into perspective for me, which is a lot of interest that I had in quantitative methodology, but also beyond that. There's a joke among statisticians that, the reason we become a statistician is because we're interested in everything but nothing also at the same time. So that way you have the tools to get your foot in the door to pretty much anything that there's data on. So, after graduation, I joined mathematics and statistics department at Georgetown University, and so been there since. I'm currently associate professor of statistics and director of graduate studies. I'll put a plug for our graduate programs at the end as part of my job. So, also I've been, as Kalina mentioned, I've been sort of active on human rights work and more on the activism side, involved in several organizations. And that's a relatively recent picture of me at a Iran protests rally, so representing Amnesty International. So, but issues that are of my interest, these are things that, again, I think my early experiences in life sort of distilled in me some ideas that I'm really sensitive to equity, justice, and human rights. I feel like I did have this interest sort of in a parallel universe to my professional life until I met a great professor, Professor Mary Gray from American University, who many of you may know. She is one of those important characters, I think, in mathematics community who really paved the way for a lot of women in mathematics. She really guided me, mentored me to be able to sort of converge these two parallel universes that I had into one. I'm also very big on climate change. I think we all are, right? I mean, we are living it, so it's hard to ignore it. But yet, there are people who do choose to ignore it. So I think it's upon us, for not because of ourselves, but for generations to come, to fight back and to make sure that, and this is not, I don't have a human-centric vision of life. So I feel like we are one of the millions of organisms on this planet and the universe. So, we shouldn't feel like we have control, but maybe we should try to clean up the mess we have created occasionally. So, and so disparities, also socioeconomic health disparities that we all are aware of, marginalized communities, invisible communities. Living in Iran, I was part of invisible community, which is you live your personal life underground because you can't publicly sort of be yourself because that's not approved, right? And so there are invisible communities within every group, every community. And so I think that's important to be able to be mindful of that when you do your research work. And political conflicts, I think that's something that whether we like it or not, it's going to affect us. And none of these are independent of each other, right? So all of them are kind of interconnected. Sometimes the connections are obvious, sometimes they're a little bit more hidden. So it's important to be able to sort of recognize those and kind of keep those in mind. So with these issues of interest, now where does this get us to data and data science? So I often think of Andre Breton's um, quote about glass house, which I think has been probably misquoted in some occasions, saying that in the future people will be living in glass houses. But I think that's fine, and I feel like this is starting to be something that we can resonate with. Yes, we don't have blankets of glass or beds of glass, but the meaning behind it is that there's a lot of data being collected. There's a lot of sensors that we're going to have in our lives. And some of us are avoiding some of that right now, but I think it's coming. It's already here. So this is um it's going to collect data on, and I'm saying it because it's a process, right? It's not really owned by anyone, at least there's it's not a um, sort of particular ownership of that, and that's sort of something that is part of the concerns, maybe. So I feel like that's also a good framework to keep in mind. And so now, thinking about, I thought it would be important to give you my sort of ideas about human rights, equity, and justice before I get into the project. So I'm going to go a little bit over some of these ideas. So one of the areas of interest that I have is science and human rights. So I'll talk a little bit about that. So it's sort of a concept that goes both ways. It's about um, human rights of scientists. Obviously, that's part of it. Science as an element that can help human rights, that's part of it too. But science as a human right is at the center of that. And it's something that, as someone who considered myself scientist, it was not obvious to me until I read about it and I was introduced to it, and then it made sense. Human rights education, I think, is important. It should be, I think, something that should be part of the fabric of our education, but of course it's not. And it can sort of leverage that beyond just human rights and say social justice. We should have that kind of we should nurture those sort of sensitivities in our kids as they grow up and they get educated. It's not all about, 2 times 2 and, all just the math or the science, but also the context, I think, is very important. Um, so there are also groups, just like many without borders groups. There's the Statistics Without Border groups. There's an on-call scientist group also. So these are sort of the areas where, as a scientist, you can get involved in human rights work and human rights projects. Also, litigation support, that's another area that you can get yourself involved in if you're interested in. Um, Although you have to occasionally think like a lawyer or pretend to do that. But I got involved in that, and I've been doing a few of these cases, and it's very rewarding. It's um, uh, oftentimes there's not much of quantitative work involved in it. It's about the perspective. Although Tarek talked to us about that yesterday, and we know that it can actually involve um, more quantitative work, like HR DAG is doing, for sure. So some of the organizations I wanted to highlight. So if you're interested in human rights work, American Mathematical Society has a committee on human rights. American Statistical Association does have a scientific responsibility and human rights committee. Pretty much any organization these days does or should have a committee on human rights or scientific responsibility. AAAS, if you're not familiar with this organization, you probably are familiar with their flagship publication, Science. So the Science and Human Rights Coalition, I've been involved with this group since 2012, I think. And so that's also a very good sort of multi disciplinary sort of area where several different professional organizations have representations in there. A little bit more about the right to science, Article 15 of the International Covenant on Economic, Social, and Cultural Rights. I can never remember that, so I have to cheat and look at it. And so, one, recognize the right of everyone to enjoy the benefits of scientific progress and its application. Two, states should conserve, develop, and diffuse science. Three, respect the freedom indispensable for scientific research. And finally, recognize the benefits of international contact and cooperation in the scientific field. And this is, you should think of science as a human rights, as something that everyone is entitled to, right? And so many countries, majority of countries in the world are signatories to this, but yet you can see that they don't follow some, or in some cases, all of these parts of the article. Happy to talk to you more about that if you're interested in getting involved in, say, AAAS work or any of the other organizations' work. Okay, so a little bit more about equity and justice. You've probably seen this cartoon or some version of it. So in fact, there's a funny story about Craig Froley, who I think is business school at UConn, and came up with sort of an earlier version of this. It's not exactly this. And then this was taken on and taken to different levels. But I think it does a very good job of describing, it helped me understand the difference between equality and equity. And of course, the part about justice is about the longer term bringing the equity in different fields, and it can be generalized to other frameworks such as environmental justice, health justice. And so these are very important issues. Now, we're still in a pandemic, I think. Nobody has said that it has ended, but at least we have our experience since March of 2020 has given us the sense of urgency for health justice, for example, the access to health. And within the US, outside of the US, you can see it domestic and the global level, there's so many issues, access to vaccine, so many different issues. And I think understanding the problem and working towards that, it's very important. All right, so now what does this all have to do with data? Well, of course, we're living in an era where we're collecting data on many things that we couldn't even dream of, collecting data on many fields that historically were not quantitative, now are adding in quantitative components. And so important to think about that. So of course, we all learn about designed or survey type of data. This is data that you basically come up with a purpose, a plan, you go out and collect the data. It may be an experiment, it may be an observational study, it may be a hybrid. We all learned that in our intro to statistics course, right? But then there are other sources of data, official statistics, administrative data, census, those type of data that states need to collect. And so that's where the inequity and disparity starts to actually show up, because countries don't have the same resources and structures. So census itself, some countries cannot even afford to do census. Some countries cannot afford to do census in the timeline of every 10 years. Some countries do census every 5 years, in fact. And so there's a range and there's variability. The last two are the more modern sort of views of data. I do work with citizen science data a lot in ecological context, especially with bird migration, where bird lovers have been collecting data and reporting it to some central location, someone who is in charge of a program. And mostly it wasn't really done because of scientific purpose. There was no, oh, I'm going to collect this data, send it to so and so, so that they come up with a scientific paper or study out of this. It was all about, well, I'm interested in this species of bird. I saw one this morning, so I'm going to write that. I'm going to share it with my friends who are also bird lovers. So that's actually, sort of the basis of a lot of this, at least in bird data. That's a lot of citizen science data, history of citizen science data, goes back to at least late 1800s. So I have worked with data from 1880, and there are even some smaller data sets that predates that. It's a um, very interesting type of problem. Organic data, what is that? So organic data is really data that is being generated, right? And so we're doing a lot of this these days, which is, I mean, the sort of the earlier versions of this were point of sales data, right? You do grocery shopping, and as your items are being scanned, there's data being collected, right? For inventory control, for example, that's being used for many years. But nowadays we have social media also. Newspapers can be viewed as part of this. So this is basically data that is being generated, and you can collect that, you can sift through it, and you can use it. Of course, there's a lot of noise. There's a lot of issues with that. So it's nothing comparable to the type of scientific data that we have. But at the same time, there's information. So there should be ways that we can get information out of these. And so there are also issues and challenges, of course. Privacy, ethics, consent, informed consent, and one of the main things is actually data equity. And that's the issue of coverage. That's the issue of access. Not everybody has a luxury of having access to data. For example, for some of us who have access to data through our institutions, like academic institutions, those data may not be available for others. Also, there are data that we can't afford to get access to, either because of security issues or cost issues, right? So data essentially is a commodity nowadays. So you have to view it as, that's, again, industries, there's an industry behind it, and that's how it's being treated. All right, so let me talk a little bit about the methods that I work with. So I'm a statistical modeler. That's what I consider myself. So I like to kind of deal with problems, come up with solutions, and these solutions have a statistical framework, but the components may be borrowed from other fields. My early education was in mathematics and applied mathematics. And so, along the way, I learned things that later on I sometimes go back to, and like, oh, maybe I can borrow an idea from this other field. And so I think that's a very important thing to do. I do a lot of hierarchical modeling, which is basically, I have a slide on that, just breaking down very complex problem into smaller pieces that are connected to each other with rules of probability, basically. Spatial statistics, time series, and spatial temporal models. Basically, these are data that are collected over space, data collected over time, and both. So there's a lot of historical data in agricultural studies, for example, but nowadays it's everywhere. It's spatial statistics, time series. Historically, there's a lot of, again, agricultural, meteorological, as well as financial and economic type of data. So, and also one of the things that I'm very interested in are complex count distributions, and specifically what we call zero modified distributions. These are basically where you have a lot of zeros. You have basically count data, but you have a lot of zeros, a lot more than your typical, say, Poisson distribution or negative binomial distribution can handle. And so these distributions can be quite helpful in that area. Other things that I sometimes use, partial differential equations. Should be very careful talking in front of mathematicians about that. Deep learning, artificial intelligence, machine learning titles, but mostly these are things that I'm trying to learn from my collaborators and my postdoctoral research who knows a lot more than me in this field, and some general ideas from game theory occasionally in certain areas of work. All right, so as I mentioned, the hierarchical Bayesian modeling structure, and there's a very good paper by Mark Berliner on this, which built this framework. He used to be at Ohio State Statistics. He's emeritus now. Basically breaking down a big problem into 3 general stages of a data model. This is where you define that my data follows a normal distribution, or my data follows a Poisson distribution, or whatever distribution. But it could also handle multiple sources of data. So it has a natural way of connecting multiple sets of data. Process models, which typically in this setting, we're thinking that observations are coming from an unobserved latent process. And so that latent process is something that you can estimate, but you don't really have observations, direct observations from, but you have the noisy observations from that. And finally, the unknown parameters that you have. So these conditional distributions. And if you're not familiar with this sort of bracket sort of notation, that's a typical sort of notation that some Bayesians use. Some kind of like to use pi or other forms of like describing probability. So that's just basically a distribution. It could be multiple distributions. And so finally, what you're really interested in is to estimate that process, the latent process, and the parameters given data. And so this can be estimated instead of doing all of this at the same time, which is a very complex problem often, then you can actually break it down into smaller pieces and multiply these and use the basic theorem really to do that. And I want to talk a little bit about sort of the general idea of spatio-temporal models, and sort of as a sort of generalization of, you can view it also as spatial models without the temporal piece, time series model without the spatial piece, although not time series models, but rather temporal random effects. But essentially, typically what you see in a regression class, right? The first regression you learn is response equal to equation of a straight line plus error term. The error term is really the probabilistic component. Everything else is deterministic. It's a straight line, right? And then the error describes the variability that you have in your data around that line. Now that error term, if you recall, that's supposed to be independent, right? So now we take this step further and say that, well, my error terms can actually be follow some kind of dependency structure, so they're not independent anymore. Or I can have an error structure that follows a spatial structure. So there's a spatial dependence. The spatial dependence means that typically the way we define it is that the points that are closer to each other tend to be behaving more similarly than the ones that are further apart. And these can be points, so you can have geostatistical data, or you may have aerial data, for example, counties. Think of rate of a certain phenomenon, an infectious disease, for example, would be a good example of that. Then you would expect that if there's an outbreak in one county, then at least for a while, the near counties, the neighboring counties may have higher rates than the ones that are farther away, because as this process is spreading, then it makes sense to have that kind of structure. And so An autoregressive structure is the simplest form, an AR1 model for the temporal random effect. Basically, it just says that the error at time t is a function of the error at the previous time point. With the spatial one, what I'm showing you here is a covariance structure that is based on an exponential covariogram as a specific form of geostatistical data, but there are other ones also. So there are many options to do this. There are many options to do this. But the idea is that you have, and you can view it two ways. One is, I want to make sure that the inference that I do here, which is the estimates of my coefficients, are reliable because they're supposed to be based on independence if I have independent error terms. So if errors are not independent, if my residuals show some kind of pattern, then these are not reliable because I have a misspecification in my model. So that could be because of this, or it could be because you want to learn about the patterns in your data, the temporal pattern, the spatial pattern in the data. See how much time there is. Okay, so I'm going to go quickly over this one. So one of the ideas of partial differential equations that I use in modeling is diffusion models. So the diffusion equation is basically the process. It's a 2D model in this case. So it's the process that explains, if you have a concentration and it starts to diffuse and spread essentially. And so there's also another version of this which may have an advection term. So you can have a concentration that moves and disperses at the same time. So this kind of model can be used as part of the process model in a hierarchical model. This is not going to be a stochastic model anymore. So it's not a stochastic PDE. This is a PDE model, and you may add error terms to it, really because of inferential purposes. What it does is that you're not modeling based on the PDE, but the PDE can inform the process. So it works as like a prior information. It's the prior information for the process. And when you don't have a lot of data, or in times that you may not have a lot of data, having a informative or relatively informative prior can be helpful because it can help with that sparsity in your data. And when you have a lot of data, then as we know, priors don't really, they don't get overwhelmed with the data. And so this can be discretized and be written as a vector autoregressive model, a vector autoregressive order one model. So that's, there's a lot of work if you're interested in this, again, using PDE models in this context of statistical modeling. I recommend reading Chris Weichel's 2003 paper. It was published in Ecology. Weichel and Hooton have a good sort of review paper on this in the journal Test. So that's the extent of my mathematical modeling. And zero modified models can be based on if you have a lot of zeros, more than what a typical model can describe. So this is like a mixture distribution of a mass at zero versus a distribution. Mass at zero versus distribution. Difference between these two models is that this one is only generating non-zero values on this portion of it. So they have a total separation of the zeros and the non-zeros, versus this one, you can have some of your zeros in this part of the model, some also coming from here. Just to give you an idea, if you have a process like an infectious disease in an area and collecting data on that, if you have a zero in your data and you're sure that the zero is because the disease is just not in that area, well, that should be going here. And then any non-zeros should be going there. All right, so I'm gonna quickly go over some of the related projects. So one of the projects that I've been working on, or an area that I've been working on, is phenology. I had no idea what it meant when first I learned about that, but essentially it's the idea of sensitivity of species to environmental conditions. And I'm probably not saying that correctly, but I think we're fine. That's basically my understanding of it. But basically, it's the idea that, for example, why is it that sometimes birds arrive much earlier than they're supposed to an area? Why is it that um, trees are starting to bloom much earlier than used to? And being from Washington D.C. area, cherry blossom is a big deal because it's not just a scientific for fun thing to do. All the hotels and restaurants in the area want to know that. So we have festivals with big prizes on predicting cherry blossom peak. And so our data that we're using here is bird arrival data. And there are several components of this. One is there's a historical program which was developed in the late 1800s by a group of bird lovers, essentially, enthusiasts. And they started writing the arrival of birds, the species of the bird, the location on index cards and sending it to someone in Washington, D.C. area who was essentially an ornithologist, but was doing this sort of as a side thing, not part of a scientific process or anything like that. And then a colleague of mine at the USGS office in Patuxent, Maryland, many years ago, probably more than 20 years ago, came across these boxes that were going to be essentially put in trash as they were cleaning up a basement. And he opened one box and realized there's a wealth of data in there. So he saved those. And then they started digitizing them. And at some point, I joined that team and started analyzing them. And we do have the group from Clemson as one of our satellites. So actually a PhD student at the time at Clemson was motivating factor in some of the analysis, who became a long-term collaborator of mine, Jason Corder. So plug for him. So the goal is understanding sensitivities to climate change. And we're not trying to assess whether there is climate change or not. We're not doing any of that. It's essentially like changes in the climate, and we know they vary spatially. And how do they impact arrivals of certain species of bird, basically? How much time do I have? Okay, I want to make sure I time this correctly. Thank you. So the interesting thing and also challenging thing here was citizen science data. This was before big data becoming so big. So I remember early on when we were talking about citizen science data, a lot of people would roll their eyes and say, oh, but this data is just, it just doesn't mean anything. And then a couple of years later, everybody's talking about, oh, my, dry cleaners can talk to my refrigerator. Like, okay, well, basically, and there's so many different versions of citizen science data programs these days. I think it's a very important factor in engaging the community in science work, but also there are problems that you can't just do that other than looking at it from this lens of science, citizen science data. There's no way you can get funding from NSF or any organization to collect data on arrival of birds in all of North America. It's just not possible. But you can actually mobilize groups of bird watchers, give them the right tools, and they can do that. They can generate that data. And of course, the data is not going to be perfect, but you did something and you collected data on something that you had no other option to do that. But then, isn't our job also to solve problems in data? Actually, a good sort of story is how R.A. Fisher, father of statistical inference, really, who was not a statistician, by the way, or even a probabilist, geneticist, came up with the idea of randomization, was to avoid the many things that I just talked to you earlier about, which was spatial statistics and time series data, all these dependencies. Well, the idea of randomization was not to worry about those dependencies issues, but there are problems where we actually want to know about those things. So it's the same thing. Yeah, we know there's bias. In fact, Jason from Clemson analyzed an early version of some of the species and identified something very interesting, that there is a weekend weekday bias in citizen science data that he was collecting, which makes a lot of sense, right? Because there are people who only go bird watching over the weekend. And so you know that. All right, so can we now deal with that bias? Can we correct for that bias? Or maybe what the term that I like to say is that, well, we can model things, right? Well, we can model bias also, right? So it's not as easy as I'm saying, but at least, a framework to think about that. So some of the work that we've done, so essentially space temporal models, we are working on PDE-based dynamical models here. Weichel 2003 has done PDE-based work here, but that's based on a survey. One of the challenges with citizen science data is also to have multiple sources of data and aggregate them. Not as challenging as Tarek was talking about with overlapping databases, with genocide, but still similar type of issues. So what we looked at in one of our projects was we looked at data on purple martins and ruby-throated hummingbirds, the two species up there. And especially purple martins are very important species in study of phenology of birds, because it's one of these long-range migrants who, from previous studies, we know that there are some sensitivities to changes in the climate. And so between these two species, we looked at a period of 2001 through 2010, mostly to the east of the Rockies. And we noticed that purple martins arrive significantly earlier than ruby-throated hummingbirds to the southern part of the United States as they migrate northward. We also did a comparison between the martins' arrivals to historical records, 1905 through 1940. This is the North American Bird Phenology Program, the boxes of data that my colleague saved. And we noticed that there's a significant shift. Basically, purple martins are arriving much more significantly in the recent years compared to the earlier period of time in the southern part of US, but are not advancing the upward migration northward is slower. Both of these studies showed that. So something has changed in the southern part of the US. Could be urbanization. We have some theories about that. Could be bird houses. Maybe a lot more bird houses are there. But we even thought about trying to collect data on bird houses from places like, I don't know, Lowe's and Home Depot and all that. But then we realized that there's some, like, I have 3 bird houses in my house that my 8-year-old built. So there's no data on that. The idea that we are now working on is, and you're probably thinking, so you're looking at 2001 through 2010 versus 1905 through 1940. So what about in between? In fact, the period of time between 1940 through 2000 are very important, especially the 60s are very important, the study of changes in the climate. But unfortunately, there were not a lot of active citizen science programs during that time either. So this program, it started to die off around World War II for obvious reasons that, well, we think it's obvious because probably people are not collecting data and they were probably active in military or something. And then it was the budget was cut and stopped by early 60s or sometimes in the 60s, and not a lot of data until sometime in the 90s. We don't really have a lot of good data in the 90s either. But we are working with the Purple Martin Conservation Association. Right now, we're doing some additional analysis. Okay, so One of the other areas of work that I'm very interested in is epidemiology. Again, putting it in that lens of sort of issues of interest. This is from the access to health care. This is from the health justice sort of indication in mind, but the connection may not be obvious here, but we're hoping that it's working towards that direction. But essentially, it's the idea of focus on two diseases, malaria and Lyme disease. So I have two sets of collaborators in this. The malaria collaborators are in South Africa, and so we're collecting data by collected by the local governments in several states in South Africa or provinces. Lyme disease is mostly in the US, and we have a focus in several states, especially Virginia, because my collaborators from Duke had a lot of good data on Virginia. But also, let me remind you that Lyme is not a US or even, well, Northwest US or Northeast US or US only issue anymore. There's Lyme disease in Europe. There's Lyme disease in the Middle East also, to name a few. So it is a bigger problem that I knew of or I could think of several years ago. So it isn't. It's one of those diseases that is rapidly spreading, and because of its interaction with the environment, it could, because of changes in the climate, both malaria and Lyme could actually have a much faster spread in certain areas. And unfortunately, there's not a lot of preparation or even understanding of the disease in areas where it's not known to be abundant at. And so it gets misdiagnosed, underdiagnosed a lot, actually. So the data on Lyme is based on CDC data. There are all sorts of issues also with the data. So although it's coming from CDC, you can talk about a lot of issues here because of misdiagnostics and things like that. We're using spatiotemporal modeling and right now working on PDE-based dynamics on this. Just showing you a few sort of results here. So for Virginia, and this is Northern Virginia. If you're familiar with this, this is the DC area, basically, the most populous part of counties in Virginia. And the disease started here, or was mostly identified, cases were identified here in 2001. This is how it got in 2016, and it's widespread now in all of the state. So you can see this movement towards the more mountain areas, Blacksburg area. And so a lot of it is because of the interaction with the environment. So our collaboration with Duke had a deep dive on understanding sort of the southwestern part of Virginia and the correlates of that. And essentially, it came down to things like elevation, vegetation density. Our own analysis showed that things like vegetation, precipitation, and relative humidity are significantly and positively correlated with the disease. But also we had this interesting, I have a climatologist collaborator who insisted to include wind and UV components of wind. And then it turned out some of these to be significant. And we don't know, we found one study that had talked about potential for ticks, since this is a tick-borne disease. Ticks may be sort of moving or wind sort of pushing them along. I don't know if that's a good theory or not, but definitely we had some results that showed that. So we are definitely looking into that more. So if you were wondering, the spatiotemporal model that I showed you, this is an example of the temporal random effects. This is an example of the spatial random effect. The spatial random effect essentially tells you that the hot spots of the disease are identified. The temporal random effect, everything else basically accounted for. The temporal random effect shows essentially everything else accounted for. There is an increase in the disease over time. These are the confidence bounds around that. Okay, so I'm going to quickly talk about forced migration. And so I'm working with a team at Georgetown. We have a institute called Massive Data Institute, which is really part of the public policy. If you're familiar with Georgetown's sort of history of public policy, foreign services is a big area at Georgetown, right? Georgetown's famous for that, not because of mathematics or statistics. so, so the several years ago, um, the Department of Public Policy was sort of upgraded to School of Public Policy, and one of the components that it has is really data-driven policy, which is a great idea, timely, right? So, and so as part of that, they have this massive data institute, and so I have collaborations with them, and one of our collaborators is United Nations High Commissioner for Refugees, or UNHCR, and so we're doing a lot of analysis of UNHCR data as well as what we call organic data, mainly things like newspapers, social media, search engine data. And so we're looking at things. Some of the methodological challenges were variable selection, because now you're talking about tons of variables. And so variable selection is not so easy. And so we're looking at the context is spatiotemporal modeling, but we're interested in not only understanding the process, the migration process, the forced migration process. And these are migration of people, by the way, because I did talk about migration of birds. So we're also interested in forecasting and really nowcasting. So basically, something that I learned from my computer scientist collaborators is the idea of transfer learning, which is if we can learn about what's happening in Ukraine, for example, then if there's a conflict kind of similar to Ukraine, then we can learn from Ukraine and adapt and build models for that new conflict. I hope we don't have to do that, but we know that we don't have control over many things. And so we'll be able to do nowcasting. And why do we need to do this? Well, because preparation for these waves of migration is important. Resources, be able to collect data. Even like organizations like UNHCR are not able to keep up with collecting data when there's such huge migrations. So in fact, right now we're looking at, so I'm going to skip the misinformation piece here in the interest of time. Happy to talk to you about that. But right now we're working on forced migration on the Ukraine case. Well, there's something about Ukraine case. There's a lot more resources and attention put to Ukraine. I'm glad that it is, but in retrospect and in comparison, of course, it is an issue when, if similar situation happens in a place that is not part of Europe, it may not get the attention it deserves. But we're seizing the moment, and we're trying to learn from this so that we can apply this to Latin America or other places. And in fact, one of the other projects that we are going to start right after this one is Bangladesh, because the climate change driven forced migration is an important factor. And it could be something that many of us actually may have to deal with. Been hearing how this area is losing a lot of land. John was telling me about some of that. So, there is climate change affects us all, right? So then we're trying to learn about that sort of process. Let me quickly talk about this one. So this is a project that is based on the idea of hostage diplomacy, which is this idea that some states take hostages, take prisoners basically, and use these hostages as leverage for political leverage, economic leverage, or often both. And so we're trying to use some of the ideas of using newspaper data, social media, or even potentially dark web data to collect data to be able to identify risk. Unfortunately, many organizations, including universities, don't have the tools that really provide these early warnings to people traveling to areas. Being in Iran, I'm familiar with so many cases of people academics actually, who traveled to Iran for a conference and then they got arrested Why? Well, because they were at the wrong time, the wrong place, because Iran is negotiating with the Western world on its nuclear program, and so they need leverage, right? So we're trying to build some models in there for that purpose. Some of the ideas of game theory that I mentioned are here. Happy to talk to you afterward. Um, so just to wrap up, so we are living in the era of digital transformation and data revolution, right? So that's great. There are lots of potential for improving all aspects of our lives as human beings, environment, all of that, right? They're exciting times for data enthusiasts and those who are experts in quantitative analysis. Lots of job opportunities, lots of career opportunities. Although that's deliberately I said job and career because some of those jobs may be soon be replaced by the same automation that you are creating yourself. But also challenges, privacy, ethical issues, inequity, essentially worsening of socioeconomic disparities. Data inequity is a big problem. And Also, we also know about misinformation and disinformation issues. So those are, I think, the main challenges of our time with this. Quick plug for our program. We do have a master's in math and stat. If you're interested in a course-only master's in mathematics and statistics, that would be a good program. A PhD in applied mathematics, which just started this past fall. So we are right now reviewing applications for the second cohort, fully funded. And so couple of quick sort of pressing issues domestically, freedom of speech, especially in academia, we know is under threat. Florida is one place I can think of. You probably are familiar with that, or folks from Florida State are smiling. And so internationally, of course, there's a lot going on, but what can we do? So one thing, stay engaged. I think working alone, is something that is becoming the sort of the default mode of work for us as scientists. But we should be. It's really our responsibility to stay engaged, take part in advocacy, and speak to and debunk when misinformation, disinformation, when you see it. It's important. Um, I think I'm out of time. So very quickly, I'm going to put a plug for my Iranian side, which is if you have not seen War on Life Freedom over the past 5 months, well, that tells us that media is not doing its job. So there's an important movement happening, a very consequential movement happening in Iran right now, a women-led movement, which is, I think, very important. And I'm not saying that just because I'm Iranian, but I think it has a lot of consequences for beyond just the one country. So be their voice, and I appreciate everyone's attention. It's been a pleasure to be here, and would love to answer any questions that you may have.